Okay, we'll get started then. Hi everyone, I'm Aditya. I'm a PhD candidate in the mechanical engineering department. Personally, I work on designing precision flow controllers for enabling affordable, robust drip irrigation for arid, developing parts of the world. But when I was organizing or trying to come up with a theme for this panel, I grew interested in a very complete demographic of farmers, coastal farmers. And so in today's panel on coastal and marine agriculture, what we're going to learn about is basically opportunities and challenges that coastal farmers across the world face today in a world when the climate is changing so much right in front of our eyes. Before the panel begins, though, I want to introduce our moderator, Charlene Chokzia, who's right here. If you haven't already seen her being mentioned in the MIT news recently, she's a fellow PhD candidate in the mechanical engineering department, and she works on designing low-cost devices for monitoring health and disease in seaweed and marine livestock farms. And that's a challenge, a research challenge that combines her passion for food and mechanical product design. So prior to that, she completed her master's also at MIT in the Media Lab in 2019, where she developed underwater communication products to help scientists monitor remote ocean conditions. And before that, she received her undergrad degree in Mechie, also at MIT, in 2017. So I'm really excited for this panel. Chuck, it's all yours.
All right. Hello, everybody. Welcome to the second panelist discussion on the topic of coastal and marine aquaculture. And we have three wonderful panelists here with us to talk about the challenges of marine aquaculture. And we'll first let them introduce themselves, starting with Trey.
Yeah. Well, thank you for having me. It's a pleasure to be here. So I've been involved in a lot of different things over my career. I started out as a software engineer and then went on to, I grew up in a meat business, and I took over that and expanded into seafood. And since the early 2000s, I've been deeply involved in aquaculture, originally to help market aquaculture products and sell them. And then later, in terms of assisting in developing technologies to grow them. In 2017, I met Sarah Redmond, who's the founder of Springtide Seaweed. So it's the largest fully integrated organic seaweed farm in the United States. We have 55 acres of farm in Frenchman Bay in Maine. We have the largest organic nursery in the United States. We also have a lab where we can store different phenotypes and genotypes for future use. We have our own processing facility. We can do wet and dry processing, and we do a lot of product development. The bulk of our species are typical that grow in Maine. They include dulse, porphyra, sugar kelp, and alaria. We also do digitata, and occasionally skinny kelp. Skinny kelp is under pressure in the wild, so we've made a decision not to grow that commercially. Our big focus is on utilizing the full water column. I think the future of aquaculture right now is heavily based on tremendous use of the surface of the water column, which takes up a lot of space. It generates a lot of interest from passersby, fishermen, kind of the NIMBY people who looking at visual impacts. And our goal is to optimize growth using the entire vertical water column so that we can get the economies of scale that are necessary without interrupting and violating the social license, which is quite limited at this point. So I'm excited to have this panel.
Joyce?
I'm Joyce Chen. I'm an economist by training at Ohio State University. I've been fortunate to work with inter and multidisciplinary teams to look at climate resilience in Bangladesh. And so that's where I'll confess to, I'm sure, knowing the least about actual coastal aquaculture of all our panelists up here today. But we do work with and survey farmers out in coastal areas in Bangladesh to understand when they transition from crop agriculture to aquaculture and what the different challenges are and kind of impediments and incentives to make those transitions.
And then we have Hauke.
Thank you. My name's Hauke Kite-Powell. I'm with the Woods Hole Oceanographic Institution, and a colleague of Loretta's down in Woods Hole on some of the projects she runs. It's a pleasure to be back at MIT. I was here decades ago as a student for much longer than I should have been. But my background is in engineering, naval engineering, marine engineering, and in economics. And I am deeply interested in the economics of aquaculture production. And my motivation for that is this fact, I think, that we need more food over the course of this century, and we need more food for people in the context of a very challenging climate situation that's going to make food production on land more difficult. So I think it's inevitable that we will look to the sea to produce food for people. Also probably feedstocks for things like biofuel and other products. And there are very interesting challenges associated with doing that on a much larger scale than we do today. It starts with social license. We've heard about that now repeatedly here already. If you think it's hard to get a permit in Massachusetts to put green coastal infrastructure in place, try getting a permit for a fish farm. It's virtually impossible. And that's in a country that loves to eat fish. The United States is one of the world's leading consumers of seafood. We just don't want to grow it here. And so that is a big obstacle to expanding ocean farming in this country. There are engineering challenges that I think are fascinating to trying to imagine large-scale integrated farms in open ocean conditions. How do you efficiently harvest in an environment like that? There are ecological modeling challenges. If you want to grow seaweed on a scale in the ocean that supports biofuel production in a meaningful way, what are the ecosystem implications of putting those kinds of farms into places where they aren't today? How do you design farms like that so that they're not a threat to marine mammals that might get entangled in loose gear? And then the whole set of biological questions about crop health and optimizing growth of the crops that you're trying to produce. So I think it's a multidisciplinary, fascinating field, and one that I think this country should be playing a much bigger role in being a global leader in than we are today. And that's the motivation for me to be involved in this.
Thank you. All right, we'll kick off the discussion by first orienting our audience on the present status of what marine aquaculture is like. It is a big topic because there's many different types. We'll kind of take a look at it from the perspective of developing country and developed country and the differences between them and the similarity. So, Trey, would you like to take it off?
Sure. My familiarity is more or less with the developing countries. The aquaculture in general is that really occurs in developed nations is finfish related to salmon. So salmon is probably the largest, and definitely is the largest aquaculture operation. It occurs both on land and in the water. It can be closed in open water pens or closed pens or semi-closed pens. It's really attracted a lot of attention because of its environmental impacts. The other areas of aquaculture that are very significant are shellfish, shrimp, seaweed, shellfish. You think mussels, farm mussels are very common. Oysters, clams, razor clams, many things can be grown. Aquaculture, urchins, we grow urchins in Maine. So there's a huge number of species that are grown, and this is all throughout the North Atlantic. So that includes the Scandinavian countries, Northern Europe, Spain, Portugal, also throughout the Mediterranean. And then on the east coast of the United States, Maine is probably the largest, but there is active aquaculture throughout the east coast, up through the Canadian Maritimes, and then the west coast from California through Alaska. the difference between, I think, developed nation aquaculture and undeveloped nations is the value of the product. In Southeast Asia, they grow a tremendous amount of seaweed to make carrageenan, and it's harvested and extracted, but it's pennies per pound. It's heavily labor intensive, so the cost structure is such that it doesn't support very expensive farming. There are many fish farms and shrimp farms in Southeast Asia, and again, it's the scale and the labor is inexpensive that really makes it attractive. But there's a totally different dynamic in countries like North Atlantic, and as well as Chile, which has big salmon farms. And those are, there isn't the social license to go crazy with this. The environmental impacts, these are wealthy nations, they don't tolerate pollution that much, they're much more sensitive to environmental issues, animal welfare issues. I mean, many people debate whether it's humane or right to farm sentient fish, such as salmon or halibut or cod. So this is a big debate. So there's so much to talk about there, but that's kind of the big difference is the undeveloped countries have large farms with low value commercial seaweeds. And the more developed countries focus on high value seaweed aquaculture that they can use up to mitigate the shipping costs. So if you're growing shrimp in Ecuador, it's less expensive to ship it to the United States than it is to grow shrimp in Thailand. And you have to freeze it in these things. So you'll find that, just on a general perspective, developed nations focus on high-value products that they can bring to market quickly and justify the increased expense and regulatory constraints and to have to deal with all the social license issues, whereas the undeveloped countries are really looking as sustenance farmers, and they look for volume, lower cost, and to provide immediate benefits to coastal communities.
And one of the big challenges that's coming out with climate change and the rising sea level is that, as usual, the poorer community are usually disproportionately affected. So Joyce, do you want to talk about the solution and the challenges of that?
Yeah, so one of the really compelling and vexing things we've discovered in Bangladesh is that with sea level rise, we're getting increased saline contamination in soils and in water sources, which is going to make rice cultivation, or has made rice cultivation, more difficult. So some people have started switching over to aquaculture, in particular to brackish aquaculture, right, to shrimp cultivation. There's not a lot, as you mentioned, right, the infrastructure there is lacking in a lot of ways. So these tend to be small operations. Large operations would be paired with multinationals or larger corporations. So there are high startup costs. It's hard for folks to get into aquaculture if they're starting from being kind of small-scale subsistence rice farmers. So some folks end up migrating away from the coastal area if they aren't able to convert to aquaculture or maintain their rice crop anymore. And then what we've started to see come up is a lot of tension actually between aquaculture and agriculture, because the folks that want to convert to aquaculture actually want to allow more brackish water in to cultivate their shrimp, right? Versus folks who would like to stick with rice farming want to do everything they can to keep that brackish water out. And there aren't a lot of good infrastructure sources or even sort of government oversight down there with permitting and whatnot to manage that interface properly. So it's also incidentally doing a lot of damage to coastal infrastructure as people look to let more brackish water in when they feel that they have to switch, or when their livelihoods can no longer be supported by rice farming and they have to switch to aquaculture. So a lot of really interesting challenges there of how we navigate, both of which are mechanisms to adapt to climate change and environmental risk, and with different implications for the future and very different distributional consequences.
And Dr. Hauke, you mentioned that integrated farming system is a potential for the farmer to adapt to the environmental changes in conjunction to creating sustainable food supply. What are some new technology or new method of farming or method that we should be focusing on in order to help do a sustainable aquaculture in the future?
Yeah, that's a big topic. I'll give you some examples, though, that are fairly straightforward. Integrated multitrophic aquaculture is just the idea of farming different trophic levels of organisms together in a way that makes ecological sense. And so, for example, if shellfish farmers are, in some parts of the world at least, increasingly challenged by rising acidification of coastal waters. So more acidic coastal waters make it harder for calcifying organisms to build their shells. If you have a large seaweed farm that the water flows through before it reaches the shellfish, that seaweed will tend to lower the pH of the water slightly because it's removing carbon dioxide from the water as part of photosynthesis. And so there's a natural combination that may make sense in certain settings. You can put the seaweed farm upstream of your shellfish operation and benefit the shellfish by that combination. The reverse may be true in certain situations too. The shellfish, some of the waste products that the shellfish generate can be beneficial to the seaweed as nutrients. And so there are ways to do that. It's probably never going to be the driving factor behind how ocean farms are designed, but it's a concept that people should consider, and increasingly, I think, are in many settings.
So right now, what are some of the biggest challenges that are facing the developing countries' coastal farmers, aquaculture farmer? And Joyce, you want to take that one?
So I really only just know the context for Bangladesh, but salinity intrusion is a big challenge. So it's really affecting soil quality. It tends to take longer for salinity to flush out of soils, and so it is. It's oftentimes a shock that subsistence farmers would have to endure for several years, right, or be able to weather for several years and have the resources to get through that. And so the consequence of that too is, right, the more migration out of those regions that we see for folks who aren't able to adapt in other ways, including through aquaculture, right, we may see more coastal erosion, abandonment of those lands, which may be optimal in some contexts, right? It may be better from a managed retreat kind of perspective. But then there's this interesting interplay too with foreign markets, right? Because a lot of the brackish aquaculture that they're cultivating is not for domestic consumption, it is for export. And so, I think as consumers too, we want to reflect a little bit about what those supply chains look like and what our demand for those kinds of products does to markets in other countries.
And here in the developing country, we are, like Trey, you were saying that there are large-scale farming operations. What are some things that we can do to make sure that it stays sustainable in the long run?
Yeah, I think right now we're at a very, kind of a tipping point. So there isn't a lot of processing. So you can grow seaweed, you can grow finfish, you can grow whatever, shellfish. But unless you have a market for them or a way to turn them into value-added products, it's very difficult. So what's happening is because there isn't, that infrastructure does not exist currently. For example, people talk about things you can do with seaweeds as an example. You can turn it into plastics, you can turn it into biofuels, you can turn it into nutrients for animal feeds. You can use it for human food. You can use it for fertilizer as extracts. But if there's no infrastructure to do that, people just grow the seaweed and they have to kind of come up with a way to sell it, to move it. So what we're doing is we're creating, because there's no market and no established market, we are kind of creating the lowest common denominator. The farms tend to be the minimum that you can do to grow the seaweed, but doesn't mean it's very high quality seaweed. People aren't investing in their farm necessarily. So to make it sustainable, we need to provide an outlet. And so we need to take people, and I don't mean this in a derogatory way, but currently I say most seaweed farmers are hobby farmers. And when I say hobby farmers, it's because they don't really have a full business plan. You know, I like to think our company is different, but we spend hundreds of thousands of dollars to process our seaweed that other people can't do. So you have to transition the hobby farmer to the professional farmer, somebody who's really looking to incorporate best practices, has the resources to make decisions that can protect the environment. So right now, a hobby farmer may reuse lobster gear or something like that, and you know, if there's a storm, the gear disappears, and so there's plastic and gear floating around in the ocean. A professional farmer would take precautions to make sure that didn't happen, make sure their gear was secure, would have ways to recover their gear if it was lost. So this is one of probably the biggest thing. We have tremendous interest in utilizing marine resources for aquaculture, but if we don't have a way to elevate that enterprise to one that's more professional and more akin to agriculture and as sophisticated, I think there's at some point we're going to lose steam, and what's going to happen is there will be a pushback from the community saying, like, you know, you said you could do this, but what you really did was you released a bunch of plastic, you made low-value products. In the meantime, you're taking that resource away from wild fishermen or recreational users, and at that point, you know, people are going to be less interested. So if we don't deal with the processing and infrastructure issues, I don't think the industry will really continue to grow. And this is why you see salmon farming as being promoted, is the salmon farms attract huge amounts of capital. I mean, billions of dollars. So they can come into a community and build a processing facility and spend $200 million and produce salmon fillets to go to your local supermarket. And so, but they practice a form of aquaculture that tends to be very much of a monoculture. They have the largest environmental impacts. So the people who can do it right and have the most money have the greatest impacts. And the species of aquaculture that would have the least amount of impacts and be beneficial, you know, have the least amount of infrastructure because we just don't attract that kind of capital.
I would echo that for developing countries too. I think we have a great opportunity right now to help identify best practices, technologies, and ways to keep things sustainable and balanced at the outset while this industry is still nascent, as opposed to getting to the point where it's really hard to reel back in various environmental consequences.
So focusing down more on that point, so in terms of food production, it's not necessarily a producer, it's like a balance between demand and the market. So we also had to add in incentives for the market to do the right thing. And then the solution to adding the incentive for the market is very different between developing country and developed country. So right now let's focus on a little bit on the developing country on this side. What are some ways to add incentive to promote sustainable demand? Anyone want to take that? Hauke?
I think that demand for seafood is strong around the world and increasing. And it may not be so obvious in this country, although we consume a lot of seafood on aggregate in the United States, and we import almost all of it. People in the US don't depend, by and large, on seafood for staying alive. There are plenty of places in the world where that's very different, where people really need the seafood because that's their primary source of protein. And those often are places also where population is growing rapidly still. They're stretching the wild stocks very thin in many cases. Region I'm familiar with is East Africa, where this is true, and the local coastal populations of shellfish have been in many places wiped out. So the only way that they can maintain the food supply that they need is to start farming. And so in a place like that, the demand is there easily. I think that also China is at a point where its population is still increasing its demand for seafood, but the local capacity to expand coastal aquaculture production is starting to get stretched. And so I think China will become more important market for importing farmed product from elsewhere. So I think in the big picture, at least, I think the demand side is healthy. And if we could figure out how to get past the social license issues in this country, the US could build a very robust, export-oriented seafood farming industry. And I think we should, for lots of reasons.
And that's really interesting, and it actually ties into, so I'm also a labor economist, so one of the things I think about a lot is immigration. And so as Trey mentioned, right, a lot of the products that we import from low-income countries are extremely labor intensive because their labor is much less expensive than ours, and that kind of feeds into this NIMBYism, right, of not in my backyard, because we can pay to have it done in somebody else's backyard. And in part, we can do that because of the immigration restrictions that we maintain, right, that does not allow workers to move across borders to where there are better economic opportunities for them and better uses of their productivity, frankly, for the world, right? So it's just interesting, I think, to think about how those things fit together, right? And the extent to which we can have industries that are degrading the, either the aesthetic value or the actual, ecosystem quality of other environments because it's not happening in our backyard, right? And we can enjoy all the seafood without having to see it grown or changing the landscape that we look at.
I think that I agree with what Joyce said. I think there are examples in this country of how that's slowly starting to change. And so one of my favorite examples is a local one from 30 miles south of Boston. There's a beautiful tidal bay near the town of Plymouth, Duxbury Bay it's called. And over the last 10 years, an oyster farming industry has taken hold there that is now supporting tens of millions of dollars a year in oyster revenue. That's a place where 10 years ago, nobody would have thought that would be allowed ever, because it's a place where there are wealthy waterfront property owners who don't want to see what they think is industrial activity in what they think is their view shed. They don't want to see gear in the water where they like to go swimming and sailing. It took years of cultivation of these people by the oyster growers, and showing up with free oysters every time one of these people had a fundraiser for their favorite charity. And after a while, people started to realize that you can coexist, that you can have a farming industry and a recreational use of the bay at the same time. And that's a place we need to get to as a country much more deeply. I think it's possible, but it takes hard work. You can't just show up and say, I want to start a farm here.
That's a really good point. And kind of jumping into that, the idea of creating a common ground of discussion for all the shareholders in play. Trey, do you have any experience you'd like to share about how do you start this conversation, or what are some best practice in terms of creating such common ground to get every shareholder together?
So as Hauke said, that's the strategy is whenever we go to our farm, we actually go to the docks where the other users are, the fishermen, the recreational users. We talk to everybody, we explain to them what we do, we invite them to our facility. The idea of dropping off oysters at an event is, just part of building community, becoming, people are afraid of things they don't know. But once they understand what you do and how you do it, and you ask their opinion about things, and they feel that they're contributing to the conversation, I think that really does wonders. So when we recently obtained a large another 20-acre aquaculture lease, and we had a hearing, and no one came to object or anything. We had spoken to all the fishermen. They were like, yep, we're fine with that. So when the hearing was held, the only people who came were neighbors who had never, they just wanted to ask questions about it, like, where do we buy your seaweed? You know, that was like the conversation. Right now in Frenchman Bay, a Norwegian company called American Aqua Farms is trying to get leases to put in 2 60-acre salmon farm sites. They'll be the largest salmon farms in North America. Actually, they'd be the largest salmon farms in the North Atlantic. And they want to put them right next to Acadia. And they did not go through that process. And what's happened is there are now 5 organizations that have raised millions of dollars to fight this aquaculture farm. This aquaculture farm would bring $300 million at least in economic benefit in the first couple of years and revitalize the entire community. But instead of building value in their operation, instead of building trust, they came in and said, we're just going to bring you jobs and you should want the jobs. Well, it didn't work that way. This is people's homes. This is the, you know, it's Acadia National Park. I mean, it's one of the top 10 most visited parks. And they pissed off the Department of the Interior, who just come out and spoken against the project. And that's unusual. The Department of Interior never tries to get in the way of commercial operations. So they took the opposite approach. They just came in and said, look, this is good for you, this is good for America, this is good for business, and this is where we want to put it. And it's been a disaster. But if you do put the legwork in, I think people respond to that. And there's always little accommodations. I mean, we have done things like, say, like, we'll just move the farm literally like 75 feet this way. You know, why? Because the lobster guys wanted a bigger channel when they cruise by. And like, cool, 75 feet doesn't mean anything to us, but it meant something to them. And whether they really needed that or not is not my decision. It made them feel like part of the project. But I think if we don't, like I always tell people, you know, I don't want to keep on beating on social license, but this is all social license. We are not going to be able to have agriculture, aquaculture, without buy-in from the community, and we're not going to have buy-in from the community unless we're part of that community.
Well, that's really interesting too, but I think it's oftentimes the opposite in low-income countries, right? Because the people there who are closest to the land, closest to, in fact, the coast, because the coasts are outside of the large cities, are pretty undeveloped, and they're pretty, you know, it's pretty risky land to live on, right? It's not well protected in a lot of cases. So they don't tend to be the ones that have the power, right, to put together millions of dollars to push out a potential corporation who wants to come in and do aquaculture, right? So it'll be interesting to think about how we balance those, you know, whether it needs some kind of international oversight, whether we need environmental standards in place, right, to ensure that corporations aren't able to exercise power over these folks who really are just looking to maintain their livelihoods.
Focusing on that point is that even so we've been kind of talking about 2 different regions, developing and developed country, but in this global economy, everything is interconnected. And once it starts really, aquaculture is already a huge industry, it's only gonna get bigger. Things are gonna get more and more intertwined. What are some ways we can make sure that the small shareholder and a large corporation can play together and play together well in harmony? Joyce, you wanna keep going?
So some things we've seen work well in low-income countries, and I can't say for certain in aquaculture, but is having cooperatives and collectives among small farmers, right, and small cultivators, so that they can negotiate for better prices and have some more market power when they negotiate with processors or transportation folks or middlemen like that. But there was some really interesting research that showed actually for coastal fishermen, once they were able to get smartphones, they were able to command much higher prices for their fish because they could call around to different ports and see where they wanted to dock to sell before they actually stopped anywhere. So I think increasingly the information technology that we have can help improve that, right? So that there's more transparency about where products are going and what a fair price is and what contracts look like.
Hauke, go ahead.
Yes, so I think you can design the rules around aquaculture to encourage small-scale operations, and in East Africa, that is actually a fairly common practice. So in Tanzania, Tanzania has a lot of coastal areas that are very suitable for aquaculture. But the country has, to its credit, turned down a lot of requests from multinational corporations to put large-scale commercial farms in for, I think, all the right reasons, and instead encouraged locals to have small-scale operations and, as you say, develop cooperatives to bring those products to the market. That's one way to do it. It takes political will and initiative and the right leadership at the local level.
Focus. Oh, go ahead.
I was just going to say there's one thing that, that would be helpful is, when, like I said, the processing and the infrastructure to do that. If we can develop, for example, we grow dulse. Dulse is a very high protein, has a very similar analysis as soybean. So it's high protein, high nutrient seaweed. It's extremely expensive to grow. If we can develop a system, even though it would never be a huge commercial product in a developed nation, like we couldn't grow enough of it in Maine to be a viable, like soybean substitute or protein substitute. If we could develop the technologies that could go to some of the undeveloped nations that have more open regulations, broader coastlines that aren't being utilized, we can commercialize there. And I think you're seeing that already with Cargill making some substantial investments in Africa, World Wildlife Fund. They're taking technologies that have been developed elsewhere, relocating them to a place where they can scale. So there's a benefit to kind of, whenever you do product development, you have offshoots. It's like, hey, we can do this, but the end product is $45 a pound. But if we do the exact same thing in East Africa, even if on smaller farms, if you can get the price down to $20 a pound, that's a huge benefit. It expands the market, by an order of magnitude. And so that's one way that we can work together and kind of develop this industry together on a global solution.
Right. One question for Hauke is that when we're expanding and when we're implementing seaweed farm, any kind of aquaculture farm, what are some positive and also negative externality that we should be considering and keep in mind and try to avoid and be aware of in developing new farms?
Positive externalities from farming seaweed, I mentioned earlier, one is the beneficial effect of absorbing CO2 from the surface waters where the seaweed is growing. That tends to reduce the acidification problem that we're having increasingly around the world today. Seaweeds also can absorb dissolved nutrients. We have over-nutrified coastal waters in much of the world, including around here. And seaweeds can help reduce that problem if you let them absorb those nutrients and then remove them from the ecosystem. So you're effectively sucking up some of the excess nutrients that otherwise might lead to harmful algal blooms or other problems. So those are benefits. You have to think about the ecological communities that are already there that you're affecting. A seaweed farm will, of course, shade the waters underneath it, and so you don't want to put it in a place where that might hinder the growth of eelgrass or something else that you're trying to promote. You have to be conscious of interactions with protected species. Entanglement risk is a big issue here in New England because of the concerns about right whales and other endangered species. So there's a big, I think, challenge in being able to accurately predict all of these ecological interactions when someone's proposing a new operation somewhere, especially a large-scale operation. And being able to model that and predict it accurately will be very helpful in building acceptance and social license for these things.
All right, now we'll move to some audience Q&A. So I have one online. Why would an integrated multi-tropical aquaculture be the main format of aquaculture? It seems like a win-win for everyone. What is the barrier?
Maybe Trey's better positioned than I am to answer this.
So basically, aquaculture, you can't use the same gear. So the gear that you would use to harvest seaweed is different than the gear you would use to grow oysters, which is different than the gear you would use to grow mussels, which is different from the gear you would use to grow finfish. So what you tend to see on multitrophic farms is that they're very segregated. So if you go to Korea, has many IMT, integrated multitrophic farms. What they're like, here's the fish farm, here's the seaweed farm, here's the oyster farm. And they all have different gear, different boat requirements, different labor expertise. So it's very difficult to integrate them all into one farm. So in our farm, again, our goal is to use the vertical water column. We do seaweed on the top, oysters and shellfish and urchins below. We're in very deep sites, so we're between 80 and 150 feet. So the seaweed only takes the top 30 feet, and the rest of the farm is down below. But it's very much two separate farms just stacked on each other. And it's very difficult. If you do that method, you need heavier boats, like we have a lot of boats now, and a lot of heavy lifting equipment. If you did it in like the Korean model where it's more spread out, you need a tremendous amount of surface area, and you have to really study flow patterns of where the water, it doesn't make any sense to have it that the water just kind of washes, through it perpendicular. You want them to go through each phase, right? So it's a real challenge. The dream is good, I like it. The seasonality works for us, actually. Seaweed is a winter crop, so we're out there using the seaweed gear and farming seaweed in the winter. And then the spring comes, we start harvesting stuff that's deeper, the oysters and the other species. But it's very difficult to do them all at once. You can't be a musician and an auto mechanic at the same time. It's very difficult.
We can field some questions from the audience, so just raise your hand and we'll come to you.
Hi, thank you for your conference, for your panel. Which are some opportunities in which digital technologies and the 4th Industrial Revolution technologies can enhance aquaculture? Like machine learning and artificial intelligence, how are there opportunities for those to enhance aquaculture?
Trey, you want to?
Did I hear the question right? Whether the use of technologies, is that what the question was? So one of the things that I spend a tremendous amount of time on is remote sensing. So what we try to do is, as Hauke accurately stated, there's a lot of carbon dioxide that can be removed from the water and nutrients. But to do that, we have living creatures, living species. So we have to meet the needs of these species. So oysters grow in certain conditions. They like a certain salinity, they like a certain pH, they like a certain nutrient. Seaweed, the same thing. So one of the big challenges, in which it's very difficult to do, is trying to analyze the water column and trying to figure out where those nutrients are, where the pH is right, where the temperature is right, and doing all those things. So we've developed and are actively developing sonde units and remote sensors that we actually can climb up and down a line that go through the water column to identify kind of the sweet spot. So we can adjust the height of the farm for optimum growth, depending on species. The hope there is that in the future, it would be automatic, that the sensors would automatically raise or lower, for example, a seaweed line so that it has optimum light, optimum nutrients, or optimum benefit to another species that's down in the water flow. So sequential, as Hauke said, you could have a salmon oyster farm next door, you want to maybe optimize that. If there was an issue with shading, it would be really great to have an automated system to do that. So we've been doing that, and we have a basic model that does that, and we're working on algorithms on how to implement that. The biggest obstacle right now is nutrients. There are no really inexpensive or really helpful remote sensors that can take instantaneous readings of nitrogen. So we can do a lot of other things, but nitrogen is like, guess what? That's really one of the most important things. So we've been working with some startup companies that are trying to do that. So I think those are really important. I think the other thing that technology can be really helpful with is aquaculture will eventually, and it's increasingly so, transition to more open water sites. And these open water sites, for example, our site is open water, it's deep. In January and December with winter storms, we may only be able to go out to the farm a handful of days. And even those days, it's fairly dangerous. To work on the farm when it's minus 10 degrees out and the winds and the waves, if someone went overboard, their survival time is minimal. If they wore survival suits, it's difficult to do work. So it's really difficult. And so you want to go to the farm as little as possible, and using either drones or remote sensing on the structure, not just on the environmental conditions, is extremely important. So we're working on ways to determine whether the structure of the farm, the lines, the buoys, the moorings, how stable they are and how safe they are. And we've set up, one of my students is here, Eli, and he set up a great system with a low rod system that we can just use low rods, goes 10 kilometers. So we can actually sit in the office and we can get a sense on whether the farm has been put under stress, and we can pick up environmental data without even leaving our desk. So this way we only go to the farm when we have to go to the farm, because when we have to go to the farm, it's A, expensive, and B, it risks the workers who work on the farm. So but I think there's many opportunities in that area. I also think there's opportunities, not to go crazy here, but MIT has a nanotechnology lab. I really think that we can work on nano inserts into the seaweed itself and use nanotechnologies to measure growth rates, to evaluate appropriate times for harvest, and whether the plants are stressed. I think that's going to be the next generation, next iteration of smart technologies for the farm.
I'd just say on the policy side, I think there's a lot of potential for machine learning to help improve nowcasting and forecasting, right, for policymakers in order to understand the impacts of potential policy changes or climatic events at a much finer resolution, right, and much faster, so that we can make adjustments in a more timely fashion.
What kind of data would you need for that?
Some of it, I think, would be, reading remote sensing images, drone images, and being able to identify, for example, like how much salinity is in the water that's coming in, right? I don't know. I'm not an engineer, but. Well,
I'll give you the data, and you do the algorithms.
All right. Perfect.
I think those are all good examples. And another place to look is in finfish farming. As finfish farms move from relatively simple near-shore cages that are easy to work manually, you manually throw food in and so on, to much more sophisticated, larger structures that are further offshore in exposed conditions. You have these same sorts of issues. You need a way to be able to monitor the activity and the health of the fish without having to put divers in the water all the time. And so it gets very basic. You want to, as a fish farmer, you want to feed the fish exactly the right amount of feed. You don't want to put more feed in than you need to, because it's a waste and it contributes to nutrient pollution. How do you know exactly what the right amount of feed is to put into a large deep water cage where nobody's there? So automatic systems, automated systems to monitor feeding activity, when you try to detect a disease event before it becomes a real outbreak, try to detect any sort of compromise to the cage structure, prevent biofouling. There's a long list of interesting engineering challenges that probably can benefit from the application of some innovative technologies. And there are companies that are moving in this direction now. Norway is one mentioned earlier as the leading producer of salmon. They have a national objective of increasing their output of salmon, their production of salmon, by a factor of 5 over the next, I don't know, 8 years or something. And the only way they can do that is to move out of the fjords where they've done it traditionally into more exposed open ocean conditions with systems that are going to rely very heavily on automation and robotics.
Great question. Are there any other questions from the audience? Aditya, do you want to go down? Awesome.
Hi. Several times you mentioned that the kelp farms can also remove nutrients from the water. I was wondering if there's any kelp farms designed only for that purpose, being used only for that purpose, and or is there an assessed economic value to that?
I'm not aware of any that are explicitly being driven for that purpose. Are you, Trey?
So Charlie Yarish Charlie Yarish at UConn did one in the East River and has another one going in now, I think. And its sole purpose is to collect nutrients, waste materials. His early work indicated that the seaweed, it was by a sewage outflow, and his early work actually indicated that the seaweed didn't pick up any of the sewage outflow. It picked up the other nutrients that were in the water. It was selective. And then he tried the same experiment. It was near a power plant in Connecticut, and it actually picked up waste from that power plant. But it shows that the plant was able to be selective, and we're not sure exactly what the differences were. But there is a growing movement to do that. There's a new farm going in the East River soon. There's also economic value in that at least Connecticut has a nitrogen credit program. So the power companies had to fund these. So if you can produce a certain amount of seaweed, they'll give you money to grow it, if its sole purpose is to remove nitrogen. I met with some legislators to see. My theory was, big ag is the largest contributor to nitrogen runoff. So why doesn't big ag have like a aquaculture fund? 0.1% of their total sales should go to this fund to fund aquaculture to help mitigate, these runoffs. And it didn't go over very well with the big ag producers. But I think that's really a potential use for it. And I think it's specific for, I've been approached by some salmon farms that asked us if we would like to have a seaweed farm near them. But if you do the numbers, the amount of waste that some of these facilities produce, seaweed will never, you just can't have, 1,000 acres of seaweed to mitigate, one outflow, So, but I think there's a work that can be done on this that can be helpful.
There are examples in Scandinavia and Europe, I think, of national rules under which shellfish and maybe seaweed farmers also can get credit for removing nitrogen or whatever it is.
Can the kelp grow? How fresh can the water be? I'm guessing the East River is brackish, but.
Was the question how fresh?
How fresh, in how fresh of water can kelp grow?
It can grow in brackish water. Okay. So we have seaweed farms in Maine that are 6-7 miles upriver from bays. So I think, if you have, as long as the salinity is there and the temperature's there, seaweed will grow, in tidal bodies pretty far. I have the exact numbers if you want for what the limits are. but I'm reluctant to give them to because like there's always an exception. Like for some reason, we've seen seaweed grow 10 miles up a river when the salinity really shouldn't support it. So we're not sure, is it the nutrients? Is it the amount of flow? Like, is there something else besides, say, salinity that makes the difference? If you have low salinity and then just tremendous flow, you're moving a lot of nutrients past the plant. So even though it may be stressed because of low salinity, if it's getting this high flow, it has the opportunity to pick up the nutrients and it overcomes the stress that the plant would be under. But the same salinity in a calm environment, the plant might die.
We have another question over here, and then we can probably take one question after that and then tie things up.
Thank you. This question is for anyone in the panel or everyone in the panel who wants to answer, but we've been talking about how to promote aquaculture in general, and I was just wondering what your opinion is on what role government should play and regulations. Is that more regulations? Is that too restrictive on aquaculture, either in Maine or in other developing countries, or just what is your opinion on the role of aquaculture, of government on aquaculture going forward?
Well, I can start. I'm sure Trey has lots to say about this.
I've said enough.
But Maine is actually an example of a state that has taken the initiative to make it easy for new aquaculture operations to get permits to do small-scale pilot projects. And then once they've been able to do that, if they can show that they're successful and responsible, there's a process for them then to get additional acreage. And in Maine, you can actually get that sort of thing done nowadays. We have a much harder time getting to that point in US federal waters, so the waters that the national government has control over, where most of the open space is, if you want to think about it that way. The permitting process there is still very cumbersome and hugely expensive and impossible for a small-scale operator really to get through. Some states have done odd things. Alaska promotes kelp farming, but has outlawed finfish farming completely. And so it's a patchwork system in this country that could benefit from streamlining. By streamlining, I don't mean less stringent environmental rules or requirements to make sure that whatever it is you're planning to put in doesn't have adverse ecological consequences. But right now, it's in most places a contentious, expensive, and daunting process, certainly for small-scale operators. And it doesn't need to be that way.
Joyce, you know this.
I think there's a tremendous potential for governments to step in with coordination issues when it comes to aquaculture, maybe even more so than with agriculture, right? Because the effects can be so diffuse of what happens in aquatic ecosystems, right? And diffuse so quickly. I think it'll be important for us to make sure. You could imagine, having a fish bill, right, similar to a farm bill every year, where we think about how we're incentivizing producers, how we help to manage prices and risk and all of that.
One thing I just would like to add is real quickly is, Hauke mentioned about streamlining and whatever. I'm old, so back in the 80s, I worked for a software company in Kendall Square, and we made video games. And I remember we made a version for Atari, if anybody knows what that is, Commodore. We made a PC version, and then there was no such thing as PlayStation. But we made an Apple version, we made a PC version. So we made 5, 6, 7 different versions. And it was really helpful. As a business, it was horrible, right? It's so much easier if you could just do it one way. But having multiple platforms, it was like, we could do better things, better graphics on the Atari platform than we could on the platforms that ultimately dominate now. it was like a step backward almost. But when you have economic forces, sometimes they want you to make it standard. Like, I really like that Alaska's doing it their way, Maine's doing it our way, and then everybody in between is trying something new. And I think, give that some time, in my mind. Give it 5 or 10 years and see which ones really work. You know, if the Alaskan approach works great, maybe Maine will adopt that, you know, and maybe people look at Maine and say, wait a minute, they really were the pioneers in this, but where has that gone? It's created issues. What were these issues? So we can learn from having multiple platforms. I'm not a guy, I mean, you know, it's either PC or Mac, right? Well, I have both. I learn a lot from both. But if I have a particular problem, I pick one over the other in terms of implementation. That's iOS and whatever. But I think that's really something we shouldn't discount, is that different regional approaches can have different solutions, and we should encourage those, not try to force feed a template. Because that's what's happening now with farming. People are growing seaweed all the same way. And you don't grow seaweed in Alaska the same way you grow seaweed in Maine. And if you have the exact same farm design, the exact same nursery, you're not optimizing. So I just want to throw that out there as something to think about.
All right. Thank you, our wonderful panelists. And we'll end with one final question. So right now the audience is filled with engineers, scientists, potential policymakers, hobbyists, and environmentalists. So what are some actionable items that we could take right now, locally here, in order to improve the status of aquaculture farming? And this is a question open for everyone.
Take a course in economics.
I can +1 that.
+2.
It's important. I think I really like the question that the other panel got too, about what is it that you want policymakers to understand? What courses would you require them to take? And I think understanding some basic ecology is critical, but understanding economics is just as important, because for better or worse, we live in a world where that's what ultimately drives what goes on. And you may not like that, but it's a good idea to accept that fact, at least temporarily, and figure out how to work with that. I think that's really important.
All right, and I think that really applies for developing countries too, right, where we've tried to come in with sustainability or conservation efforts. They don't work well unless we're able to provide economic incentives, because at the end of the day, conservation is a luxury, right, for right now. And that's how people view it. They need to support themselves and their families, and they'll do whatever they need to do that. So we have to make the economics of it work for them too, not necessarily a huge profit or something, right? But just the basic economics of it have to add up as well.
Yeah, and I just say, if, you know, for the engineering students, like, you gotta leave campus and go to where seaweed is grown or aquaculture is done. You don't appreciate the problem until you see the problem firsthand, until you go out on the water. And so I would really encourage, you know, and we offer that. Anyone here could call me up and we'll bring you out to the farm and scare you. And then, but also the second thing is, whatever projects you work on, you know, make some friends in the marine botany or the marine, you know, the marine biology section. Find the people who know what these species like, learn about them, because I have so many engineers that I work with that come up with brilliant solutions, but they just kill everything. So the whole idea is not to kill anything. The solutions are great, you know, and we love that. So get out there, see what it's like on the ground, to understand how the users of your technology, how it will be implemented and where it will be implemented. And the second thing is make sure that your technology isn't just a solution to a problem, but it becomes part of the ecosystem of keeping living creatures alive, that they can have commercial value and benefits in terms of food or whatever other products we can make from them. And that invitation's sincere. I mean, if anybody wants to drive 6 hours up to Maine and put on some foul weather gear and go out and see what a seaweed farm looks like or an oyster farm, I'm glad to set that up for anybody.
Count me in. Round of applause. Everyone for an amazing discussion.